Hey, everybody. So sorry I'm not there today, but I do want to take this time to go over some exponent properties, okay? So remember that on this quiz on Tuesday, you're going to have all sorts of exponent properties as sort of like half the quiz. Remember, this quiz is going to be a 6-1 to 6-4 quiz, right? 6-1 to 6-4 quiz. Remember that sections 6-1 and 6-2 were all exponent properties. Exponent properties. We haven't done that in a while. It seems like it's been a really long time because of the snow day and everything, a long weekend. But the section 6.1 and 6.2 were all exponent properties. Section 6.3 and section 6.4 were all about exponential functions, right? So it's been a minute since we've gone over the exponent properties. So that's what this video is here today. So you have basically a couple tasks. The first thing that we're going to do is we're going to go through a warm-up. So I'd like you to get out a separate sheet of paper, and we will do the warm-up together. I'm going to ask you to pause, and then we'll go through the warm-up together. The second thing that I would like to do is example 4B out of yesterday's notes. Okay, we did not hit that second compound interest formula problem, so we're going to hit that. It's just sitting over here. The third thing is okay, I'm going to call it our notes for the day, but it's basically the review of the exponent properties. Now that the sub should be passing out to you. If you do not already have that, please get that from the sub. It's the page with the properties and the examples going down the middle column. Okay. Now, I am going to insist that you pause the video right after those notes and then come up and show the sub that you have those notes completed. Once you show that you have the notes completed to the sub, then she will give you the homework. Now, the rest of the time is yours to work on the homework. However, if you'll notice down here, I am going to go over 1, 2, 3, 4 of those problems from the back of the homework. One of the couple more harder ones, I'm going to go over those within the video. Okay. So these are your 4 tasks today. We're going to do the warm up together. I'm going to ask you to pause and do that. And then we'll go over it. I'm going to go through example 4B. I'm going to talk through the exponent properties again, and then we'll go through I'll go through some of the homework problems. So without further ado, let's get started here. I'd like everybody to pause and try this problem. I don't know. I thought the fish looked a little funny, so I just added. I could have edited those out, but So go ahead and pause this. A young channel catfish weighs about 0.1 of a pound. During the next 8 weeks, its weight will increase by 23% each week. Write an exponential growth function that represents the weight of the catfish after t weeks, and about how much does the catfish weigh after 4 weeks. Okay, so go ahead and pause and try both A and B and just see how you do. All right, now I need to use the exponential growth function. Okay, exponential growth. How do I know I need to use exponential growth other than it's telling me I need to use exponential growth? Because I see increasing by a percent. Increasing by a percent. Whenever you see increasing by a percent, you use exponential growth, which is y is equal to a times 1 plus r to the x power, where a is your initial amount, r is your rate as a decimal of increase. So in this case, y is equal to, my a value is 0.1. That's my starting weight of the catfish, 0.1 of a pound. And then I have 1 plus my rate. Now my rate in this case is 0.23. 23% becomes 0.23. Okay, raised to the x power. So now I say my final answer for part A is y is equal to 0.1, why did I write the plus sign again? 1.0 or 1.23 raised to the x power. Now, part B says, I want to know how much the catfish weighs after 4 weeks. So y is equal to 0.1 times 1.23 to the 4th power. So now I'm going to just go in here and I'm going to say 0.1 times 1.23 raised to the 4th power. And that is 0.2288. So I'm going to say 0.23. 0.23 of a pound. Okay, and that's my answer. All right, so hopefully we did all right with that. Okay. Now, I'd like, if you need to, you should get out your guided notes from yesterday. Remember, if you don't have your guided notes, I always put the extra copies up in the bin, so you can kind of get one of those if you need to. All right, so write a compound interest function to model the situation. Now, remember what the compound interest formula is. Y is equal to P, the principal, the original amount, 1 plus R, our rate, over N. Now, that is, remember, N is the number of times this function is compounding. So if, say, it's compound quarterly, that was 4. Compound semi-annually, that was 2. And then it's times to the nt power. So in this particular one, I'm investing $15,000. My R is nope, not 0.48. That'd be 48% interest. Ooh, take my money. 0.048. And then N, since it's compounded monthly, how many months are in a year? 12. And then I'm going to do it over the course of 2 years. Now, I shouldn't expect to see so much growth because I'm only going 2 years. Okay, so don't think that this is going to be like, oh, I'm going to get $1 million. No. Okay, invest $15,000, and then it's 1 plus 0.048 over 12 raised to the 12 times 2 power. Okay, so let's go ahead and evaluate there. I'm going to take the 0.048. I'm going to divide by 12. And then I'm going to add that to 1. Okay, so that's going to get me 15,000 times 1.00004. Yeah, 004 raised to the 12 times 2 is 24th power. So that means over the course of 2 years, it's going to be, okay, we got 15,000 and 1.004 raised to the 24th power. That's going to be 16,000. So it's getting $1,000. That's pretty good, I would say. So it's 16,508.22. 16,508.22. Okay, so over the course of the 2 years, with 4.8% compound interest, compounded monthly, over the course of 2 years, 15,000 is going to grow to 16,508.22. Now, just as a reminder, I did this later in the day yesterday, but you may be thinking, oh, compounded monthly, that's got to be way more than if I had just done a regular, yearly exponential growth. Think about this for a second. If I had not compounded monthly and I just did our plain old exponential growth formula, that would be 15,000 times 1.048 raised to the 2 power, right? Because that if I don't account for this 12, it's just my regular old 1 plus 0.048. That's my just plain old exponential growth formula. So what if I had not compounded this monthly? What's my benefit of compounding this monthly rather than compounding this yearly? Well, if I've got 15,000 times 1.048, let's see how much of a difference this is actually making. Raised to the second power in this case. Oh, so it's only like, okay, 16,474.56. 16,470, get out of there. 474.58. Okay, so how much of a difference is this actually making? Get out of there. Well, this is really only making a difference of like 20, like a 30, I don't know, $28 or something like that. Okay, it's really not making that much of a difference. Okay, that's like $34. But anyway, it doesn't matter. It's not making that much of a difference. Okay, in the grand scheme of things. I mean, money's money. Go for whatever does better for your money. But still, it's like some people have this false idea that it's going to make it like $1 million more or whatever. I don't know. All right, so let's go through our exponent review. Okay, so you should have your guided notes out now. And what I'd like to do now is go through an example of each type of the properties and show you what the property looks like and what an example would look like with it. All right, so our first property that we have is the zero power property. Remember, anything to the zero power is 1, right? So this 31.8x to the zero power is 1, okay? Remember, a to the negative n. What happens with a negative exponent? Remember, the negative exponent makes it go down to the denominator and make it positive. So in this case, now remember, is the 2 happy? Yeah, don't move the 2. The 2 stays on the top. The x to the third goes onto the bottom. And there's my answer. All right. Now remember that if it's already in the denominator, pause wherever you need to and just stop and rewatch if you want to, whatever. If I go too fast, just pause, slow it down, rewatch it. Remember that if it's a negative already in the denominator, then all you're going to do is just move it up to the numerator. So this is just a to the positive n in this case, right? Okay, so I look here. Is A happy? Nope, move it down. Is C happy? Nope, move it up. Is D happy? Yeah, that's an exponent of 1. Okay, so there's my answer there. Okay, let's take a look at the next one. A to the m times a to the n. Remember, if I'm multiplying with the bases, I add the exponents. So in this case, I've got f to the third and f to the negative 7th. So that means that's an f to the negative 4th. And then we have g to the first times g to the 5th, which is g to the 6th. Now remember, I cannot leave a negative exponent in an answer. That's not happy. Move it down. The g to the 6th stays on the top. The f to the 4th moves down to the bottom. And there's my answer. Okay. Take a look at the next one. Remember, power to a power, that's the one where I multiply the powers. So this would be like a to the m times n, right? So in this case, this is m to the 4 times 6, 24th power, okay? Here's this one, a times b to the n. Remember, this is the one where I distribute the power to both pieces on the inside. So this would be a to the n times b to the n. So in this case, this would be, okay, we've got negative 2 squared x to that. Now remember what I do with these powers. I multiply. Power to a power means we multiply. And then it's y to the second. So the only thing I have left to do is just take this negative 2 squared, which is a positive 4. Okay. All right, next one here. Now remember what I do with the division property of exponents. I say if I'm dividing with like bases, I subtract exponents. A to the m minus n. So in this case, this is x to the 5th over x to the 2nd. That is x to the 3rd. And then y to the 1st over y to the 7th. That would be y to the negative 6th. Now remember, you cannot leave the negative exponent. That negative exponent must move down to the denominator. It's not happy up there. So therefore, it would be x to the 3rd over y to the 6th. Let's take a look here. I've got a over b to the n. That is again, we distribute that power. Same thing as the product property, but I'm going to distribute that power to both numerator and denominator. So that would be a to the n over b to the n. So in this case, I just distribute that power to everything on the inside. That would be 2 to the 4th, n to the 12th, m to the 8th. Just multiplying by 4 there to the numerator and denominator exponent. Now, remember that I'm not this is not becoming 8, right? 2 to the 4th is not 8. You can't just multiply those. That is 2 to the 4th power is 16. Okay, 16, n to the 12th, m to the 8th. How am I getting that? Well, just put it in your calculator. Go 2 to the 4th power. All right, let's take a look at the next one. Now, remember, if there's a negative exponent on a fraction, that means I'm going to be taking that fraction, since it's a negative exponent, flipping the fraction, b over a, and then raising that to the positive power. So that would be, again, just b to the n over a to the n, basically, right? So flipping it and then reverting back to this quotient property. So in this case, that would be 3 over x to the 6th all raised to the positive third power, which when we distribute that would be 3 to the third. X to the 3 times 6 here is 18. So 3 to the third is 27 over x to the 18th. Okay, now I'm actually going to have you add in another one here. Just remember that if you've got a fraction, this is the only new thing from section 6.2. Everything above was from section 6.1. This is the only thing from section 6.2, this rational exponent stuff. Remember that this is the power, and this is the root. Okay, so remember that there's two options here. I could take the power first, take a to the m, and then take the nth root of that. Or you could take the nth power of a, then raise it to the m, or sorry, the nth root of a, and then raise it to the m power. Either one is fine. So if I look at this x to the 2/3, that would be like saying, okay, I can take the third root of x and then square whatever I get, which is also equivalent to saying x squared, and then the third root of that. Now, what I'd like you to add in here, somewhere on the margin, somewhere off to the side there, is going the opposite way around. So if I've got like the fifth root of x to the 7th power, and I wanted to turn that into a rational exponent, remember that you should be able to take this and turn it into x to the 7/5. Okay. So know that you should be able to go this way, or you should be able to go this way, taking it from a fraction exponent to a radical, or from a radical to a fraction exponent. Okay. All right, now this is the point where I am going to ask you to pause. Please pause the video, show the sub your notes, okay? So you can get the homework. Oh, awesome handwriting there. Look at that, fancy. Okay, so pause the video, show the sub your notes, and come back and get the homework. And then you can actually start in it for yourself, but I'm going to go through 4 of these homework problems. So I'm going to do 4 homework problems for you. So you might want to watch the video, just saying. All right, so let's take a look at some of the homework problems. You probably paused and have the homework by now. All right, let's take a look at this one. Holy chicken nuggets, look at this one. What are we doing here? All right, let's take it step by step. Again, I would strongly encourage you, if you're confused on what to do, just take it property by property. See, like, if I ignore this right side here for a second, if I just say, okay, just hide for a minute, what do I do with just this? Well, aren't I just supposed to distribute that power? Okay, well, let's see what that does. That's 2 to the 2nd power, which is 4, x to the negative 5th squared, which is multiply x to the negative 10th, y to the 8th. Okay, well, now let's see what we do here. Oh, okay, so I just distribute that power again. Times 3 to the 9. Okay, 3 to the 2nd, which is 9. I'm just going to go straight to saying 9. X to the 8th. Y to the negative 2nd power. Now, remember that this is all multiplication. So this is kind of like that, just a multiplication property. 4 times 9 is 36. Okay, x to the negative 10 and x to the 8th. Remember, power, I'm multiplying with bases, so I add the exponents. That's x to the negative 2nd. And then y to the 8th times y to the negative 2nd. Add those, I get y to the 6th. Now remember, I've got a negative exponent in there. That's got to go away. The 36 y to the 6th stays on top. The x to the 2nd goes to the bottom. And there is my answer for number 10. Okay, so again, I encourage you to just take it step by step, and maybe that would help you. Same thing here. Okay, now let me remind you, is that 14 being raised to the 4th power? No, 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 don't do that to yourself. All I'm doing is taking that power to a power. So that is 14 x to the negative 12th over, okay, so that is 2 to the 3rd, which is 8 x to the 6th when I distribute into the x squared to the 3rd. Now from here, remember that this is a fraction. This 14/8 is a fraction. Reduce top and bottom by 2. Okay, 7/4. And then negative 12 minus 6. Now remember, negative 12 minus 6 is negative 18. So that's going to give me x to the negative 18th on top. Okay, negative exponent, not happy. Shift it to the denominator. 7 over 4x to the 18th. That is my final answer. Okay. We're taking a look at number 23 now. Okay, negative exponent on a fraction. Flip the fraction. Oh, what is the reciprocal of 1 over 8? Isn't that just 8 over 1? Right? Or just 8? Right? So this is just technically 8 to the positive second power minus, okay, flip 1 over 2 becomes 2 over 1, or just 2 raised to the positive fourth power. All right, 8 squared is 64. 2 to the fourth is 32. All right. Oh, wait, no. 2 to the fourth is not 32. 2 to the fourth. 2 to the fourth. 2 to the fifth is 32. 2 to the fourth is 16. So it's 64. Oops, that's the eraser. 64 minus 16, right? 64 minus 16 is 48. There's my answer. And the last one I'll do here for you. Look at like basis of dividing. Remember, division means subtraction. Now be careful here. I'm going to take 3x and then subtract away this entire exponent. So I've got to kind of like put that in parentheses. And now what do I do with the negative here? Yiboop, yiboop. Distribute that negative. So that becomes y to the 3x minus 3x plus 3. Now what happens here? Cancel. So this ends up just being y to the third. Okay. All right, so hopefully we've watched this entire video. Hopefully you guys are having a good day. You can now just work on the rest of the worksheet, finish that up for the rest of the period, and then we'll come back on Monday and review the rest of the chapter, and then we'll quiz on Tuesday. So yeah, I will see you guys on Monday.